Welcome back, everybody. Starting a new one today. This is a Space Encounters. Just got it out of the box, put it down. And after just looking at it, well, this cap I can tell is bad because it's loose. And all of these are probably bad. That's a very common thing on these Midway boards, are these 10 microfarad caps are most likely not good. They're probably open. At least half of them are probably open. Or some of them anyway. Okay, we have nasty ROM legs. These sockets suck. So we've got connection issues here too. All of these chips right here need to be cleaned. All the legs are tarnished. And the sockets are going to need to be replaced so that we have good connection from chip to socket. All of these will have to be, resoldered. All of the connections will need to be resoldered. That is preliminarily. I'm going to replace these with electrolytics. These are the 12-volt filters. And I don't like these because they like to flame out. These guys right here. So I'm going to get them off the board and replace them with 22 microfarad electrolytics. And yeah, that'll do. But first thing I'm going to do before I do anything to this, I'm going to put it together and we'll see what it does right from the get-go. And then we'll see what we have after we do all of that aforementioned maintenance. So let's go ahead and get this thing. Let me get my harness set up out and everything for Space Encounters. Hook this thing up and see what we get. Okay, I got it all hooked up and I had to change something with my setup because I got really tired of, if you run this on a switcher, you cannot get the voltages right. Now, if you recall, the Midway 8080 power supply has a pot on it to adjust the 5 volts, a pot to adjust the 12, and a pot to adjust the -5. If you don't have that, it is pretty much impossible with a switcher to get all of the voltages where you want them. If you get the 5 volts up to 5, then your -5 is going to be at like -5.5 volts. And the 12 volt line will be almost 13 volts. So I decided to go ahead and power the -5 and the 12 from my switcher, and I am now powering the 5 volts from my AR. And it's a lot better. It's more erring on the safe side. I tested my voltages, and I'm about 475 on -5, about 12.2 volts on 12 volts, and 475 on 5 volts. I'd much rather have that a little bit on the low side than, say, be way high on the voltages, which is what I had to be. You know, otherwise, if I wanted to get 5 volts, even close to 5 volts, I could only get about 4.5 volts on the 5 volt line before the -5 was up near -5.5 volts. So it just didn't work out right. Anyway. So I made that little change. And I've got this thing powered up, and this is what we get. It's just the column, if you will, is not right. And that would be an issue on that game board, the back PCB. Probably just got a bad logic element on it. So we'll look into that, but I am going to, before I do anything, this is our starting point. So this is actually a pretty good starting point. But one thing I want to do is make this board much more reliable into the future. And by doing that, we need to do a lot of maintenance on this board. So, yeah. So we'll go ahead and do that, and I'll be back. Well, I just wanted to point out, in starting my maintenance, I popped the top off of this CPU socket, and look at this. This would definitely be an issue. This looks like a broken pin on pin 40. Whatever is going on there. That would be intermittent at best. Yeah. So, yeah, that had to be replaced. I got all the tops off. We'll go ahead and just pick those all out and replace them. I'm going to replace these caps, and we'll do a little cap testing. We'll probably do that next. Test out some caps and a little capacitor fun. Here's one of the 10 microfarad caps that was on the IO/game PCB. It's supposed to be 10, and we get 1.9. That one is almost open. Here's one that reads, this is a 10 microfarad that reads 0. Yeah. Well, it's kind of touching. Let me rearrange that. All right, yeah, now they are not touching. And it's still 0. Oh, yeah. Yep, 0. Yeah, and when we put it on the ESR meter, no ESR, which means it's open. Every capacitor has some ESR. This one doesn't. This one's just open. And here's another one from the main board. Open. And this is the video capacitor on the main board. And it's a 10 microfarad. You can see it reads 5.4, 5.3 microfarad. And what that means is this has an extremely high ESR, I believe. So let's put it on the ESR meter. It should be, it's a 10 microfarad low volt. It should be around 1 ohm. About 1 ohm, 1.5 ohms of ESR. Let's see what it reads. I just put that cap. This is the video cap, remember, that had half, it was a 10 microfarad cap that read about 5 microfarads. Should be about 1 to 1.5 ohms of ESR, and we have 67 ohms of ESR. Yeah, terrible cap. So, yeah, needs to be done. That video, this was on its way to being open. So, yeah, the video, I noticed that the video, if you go back and look at the beginning of the video, you'll see where it was kind of, the video was a little shaky up top and it didn't look great. That was because of this. So it'll look, see, that's climbing. It just keeps climbing. Yeah, so needed to replace. These caps were terrible. I always see this on these Midway boards. This is very common. These caps all have to be replaced. This is the progress update. I just got all of the sockets removed and the pins. I still have to clear out all of the solder out of all the holes. Removed this guy. I removed these caps. I removed all the electrolytics. And we'll finish this guy up. Have it populated, and then we can go from there and start actually doing some troubleshooting. I've got all of the chips cleaned and dried. All of the legs are nice and clean. So yeah, cool. We'll get this thing finished up and go from there. Right, and now I have all of the holes cleared out, pretty much. Might have to go and touch up a few places. So now we're ready to repopulate. I'll do a really good inspection, make sure nothing's shorted, clean up a little bit. But preliminarily I looked at it and it looked good, but I'll do a closer look. Populate everything and we'll be ready to start our troubleshooting. Okay, so all the cleaning and repopulating is done. I didn't have any 24 pin sockets, so I just put 28s in. Got our new caps, and I've cleaned the back side of the board really nicely. No fluxy residue mess. Okay, I have gone and replaced the caps on this board. And I resoldered all of these pins. And I cleaned. Got everything resoldered and got everything cleaned up. So yeah. Now I got my brackets out. We're going to put this thing together. Flip it over so we can get to this PCB. And just start poking around. Start doing some general poking around on the thing. See what we can see. See if there's anything obvious that we find. Right, got it hooked up with the brackets on it. I've actually got it hooked up and turned on, and we get the same thing. The background and the column and everything is just all messed up. Yeah. So we'll get that all figured out. Go ahead and flip this thing over so that this board is facing us, and that way we can start poking around on it. Okay, got it flipped around. I got the little scope turned on. I'll turn this on and start just doing a little bit of poking around on the thing. Okay. Alright, I'm going to have to get the, what is this chip right? Shoot, I don't know. I'm going to have to get the tripod out, set this thing up. I'm going to do a little poking around. If I find anything that looks funny, I'll come back. Okay, so right off the bat, I have 3 points of interest just from poking around. I have number 1 interest is on, it's an input to these 153s, and it's that. I don't know what that is supposed to be, but that doesn't look very good. I have to get the schematic out to find out where this comes from and what is this. That's first. And the second and third are a couple of RAM chips. There's a RAM right here, 7489, and there's a RAM right here, a 74S201. So there's 2 RAMs on here that those are just about, you have to pull them and test them to see if they're any good. And yeah, so first thing I want to do though is I want to look at the schematic and find out what this is supposed to be. What is that? What is that? What is that supposed to be? Let's do this. Let's slow this zoom in a little bit. Yeah, that just looks weird, don't it? That just looks a little strange, doesn't it? What is that? So, yeah. Some weirdness. So let's do that. Let's get the schematic. Find out what is the origin of that weird looking signal. Is that just No, it can't be just a floating line. They wouldn't leave a floating input on a 153. So that's got to be something. So we'll figure out where that's coming from. And then I might have to just, for elimination's sake, pull and test the RAMs. There's 2 RAMs on here that, I think there's only 2, hopefully. Because there's some 83s. I see a couple 83s right here. Those are adders. And then there's some 38s. And then there's this RAM. This RAM, this RAM. So, yeah. That's where we'll start. Okay, I got the Space Encounters Logic PCB schematic out. And I got, looking, here's those 153s. And you can see on each one of them, pin 3 and pin 13 are unconnected on every one of them. So, yeah, that's just some kind of residual noise, if you will, that's on those. On pin 3, how I showed this. Yeah, it's just nonsense, noise, transient noise and whatnot. So that is a non-issue. So we've got adders that could, those are probably for sprite positioning, I would think. I don't know, let's look at it. Let's find those adders on here. Right here. And we got 191s. Now, it's hard to tell what's what on here. Here's a RAM. This is probably a buffer RAM. This one right here is probably the line RAM. That's this guy right here, which that's probably fine because I don't see any line issues. The other RAM is right here. And it is outputting bits that are muxed and then basically control all of this. Yeah, these are just, this is a line buffer right here. Yeah, I'd have to look at this a little closer, a little more detail. Like, what is this? This is control. We got latches. It's probably going to do with stuff going to the audio board. Yeah, this is probably controls and audio stuff, I would think. This is control stuff, actually. Control stuff is over here. This stuff is data that goes up to the audio board. And then all of this is the game on here. With the moving characters. And I don't know, let's just try something. We got a counter at L5. And right here, L5. And if I mess with it, it totally screwed everything up. And it reboot and came back. Let's do 6 and 7. Okay, that does not affect the moving play characters at all. See that? So this thing is in background. So I'm going to say this is the background stuff. The play field, if you will. That's where I would focus my starting on. And I would actually like to go back to my initial thing and pull this RAM right here and test this RAM, because it outputs bits that basically control all of this. Yeah, so first thing I want to do is pull that 7489 and just run it through my Inquisitor, test it, and then we can start on these. We got some adders here. There's 2 muxes and 4 counters. There's a lot that could go wrong in that. So that's what we will start with. Okay, so with this RAM verified, I removed it. It's fine. Nothing wrong with it. Socketed it, put it back in. And now it widened out a little bit. So yeah, something's funky on here. So that RAM was right here. Now we have a mux right here. Simple gating chips. So let's start. And then we got a lot of circuitry right here, this 75. I think that's going to be more along the lines of, well, I'm not exactly sure. I know this right here is when the screen goes white and flashes white. That's this circuitry right here connects to the video out in varying degrees based on the inputs to this. Will make it varying degrees of white where it flashes, I guess. I suppose. Okay, this is all of the background. So this is where I'm going to focus. I'm going to start at the beginning. I'm going to start with this mux right here. 157 mux, and it looks like it's always enabled. It looks like pin 15 is grounded. And that's good. Because that is always enabled, I can test it with the little scope. I only need 4 inputs. I need select, in, or select, A, B, and out. So I can do that with the little scope and make sure it's working right. So we'll do that. Then we'll move on. That's this guy. And then I'll move on and I'll do this R3, which is a 02. And then we'll move on to all of this. This is a little more intricate. These well, these are 298. Those are muxes. We have adders here, and then some counters. Yeah. So that's the way we'll work at this. Start here, move this way. Okay, I'm ending it tonight on the note that I went through and checked a lot of parts. These 175s, I was able to use the little scope to do those. 157, some of the gated stuff. 157 mux. I could probably do the 298s, as a matter of fact. I'm done for the night, though. I'll probably do that tomorrow. It depends on how many inputs I need. How many probes I need. If it's just a 2-input mux, let me see. I don't know. It is looks like it's got 2 control lines. Okay, and this one is yeah, those are signals. So there are 2 signals that are controlling this 298, so I have to use the analyzer. So tomorrow will be analysis day. And I'm going to start with the 298s, the 83s, and the 191s. And we'll see what we see. Okay, we're looking at this Space Encounters. And I got some good news, and I got some bad news. Let's start with the good news first. I have found a bad part. And it's a 298. I've got my big TTL book out here. A 298 is a quad 2-input multiplexer with storage. And what you can do is, I treat it as a dual 4-line mux, basically, where you can hook up 4 bits to the input, 4 bits to the output. You have A1, B1, you have A, B, C, and D, basically. Now hold on a second. Why does this say a quadruple 2 input? This is a double 4 input. This just doesn't seem like that's not a proper description of this. This is a dual 4 input word selector with storage. That's weird, because it's got 2 words. Word 1 and word 2. A1, B1, C1, D1, A2, B2, C2, D2. Those are the 2 4-bit words, and it outputs, that's the 4-bit output. What this does, it has a write select, basically, where it writes, it chooses which word it wants to write into the output. Okay, and it's got a clock, and it works on the negative edge of the clock. And depending on whether write select is either low or high, here's the truth table. Word select, not write select. When word select is low, it selects the 1 word. And see, it's a 4-bit word. And when word select is high, it selects the higher word. And it stores it as long as the clock is high, all operations are inhibited, and it stores the last output. That's how that works. Anyway, okay, so there's a 298 right here. I went over that one, and it works fine. This one did. And then I moved over to the second one, and if we look at it, remember, it works on the negative edge of the clock. And right here, oops, we see that word select is 0. So it's going to select the 0 word, right? So on the lower edge of the clock, it'll output what's on word 0. And word 0 is F the whole time. So it is F the whole time down here. That's correct. Let's take another snapshot. Here on the negative edge, it's supposed to be outputting 7, and it's still F. And then it goes low again, and it samples whatever's on word 0 and sends that out, and it's still F. Here it's supposed to be F the whole time, because this is F the whole time. Same here. Right here it should be 7, and it is 7. And then on this it should stay 7, and it goes to F. F the whole time. F the whole time. F the whole time. Seven, and it goes to 7, and it stores that as long as this is high. As long as the clock's high, it stores 7, and then it should go to F, and it does go to F. See, it goes low right here, and F is on 0 word, so it goes. So that is correct. F the whole time. Here it goes low on 7, and it should have stayed 7. It went to F though for some reason. And then it went low right here on 7, so this should have stayed 7, and it did go to 7. This should have been 7 the whole time down here. So this thing does not work. Let's just move our trigger, and let's trigger on selecting the other word and see what happens. Now it's selecting one word, the word on the 1 line, and it goes low right here. It should have went 2. It should have went 2 and it went 7. Here it should be F and it's 7. Here again, F, 7. See, it should be 2. I'm sorry, it's selecting word number 1. So it goes low, it should have went 2. Instead it says 7. Same thing, it should be 2 and it's 7 the whole time. So this thing's not working. Now it should be 1. See that? It goes low and word 1 is 1. It should have went to 1. So this mux is really, really bad. 4-bit word selector. It's not a mux, it's a selector. And that is K5. And let's just look at K5 here. K5 is this guy. So yeah, so we're getting faulty information into the counting, and yeah, so we got to replace that. Now for the bad news, I don't have any 298s at all, so I am going to have to put this aside, and I don't think I have. I will look through my stash of boards and see if I have a 298 that I can scam. I don't know if I do or not. Hopefully I can grab one out of a parts board. But yeah, this guy needs to be replaced. So if I don't find a 298 in one of my parts boards, I'll come back and let you know. And if I can't, I'm going to upload this as part 1. Because I don't know, it's going to take a while to get parts. So, alright, I'll be right back and let you know if I've had success at scavenging a 298. Alright, yeah, no, I searched high and low and I do not have any 298s. So I've got it marked with a red dot. That one's got to get replaced. I'll upload this as part 1 and we will continue this once I get parts. Bummer. Alright, stay tuned. False alarm. I just got to looking at, I have a couple Milestar, whatchamacallit, Mach 3 boards, and they have a 298. So I'm going to pull this 298 out of here and pop it in that. Space encounters. Okay. Right here is that part that we got from that other board and put in there. And we are running Space Encounters. And look at that. We've done fixed it. Well, shoot dang. And it sure does look perfect. Got the nice white flash. That zoom out's looking good. All right. Excellent. So we got to utilize the logic analyzer and find a bad part, which was kind of fun. That's always fun. This thing uses analog controls, so I can't readily test the controls on this thing. It's just once the customer gets it back, they're going to have to try it out, I guess. And you know what I'll do is I'll look at one of my old videos and see, did I actually test controls? I kind of think I may have. I don't remember. Sounds, I know I cannot test the sounds because I don't have a soundboard. And this uses a separate soundboard, so that I know I can't do. Yeah. So what I did on this board set, let's do a little bit of a recap. I replaced all of these sockets. I cleaned all of the ROM legs. They were all tarnished. I actually put a new 8080 in it because the one that was in it had a broken leg on pin 40 and it fell off. So I just replaced it. So yeah, the solder did not stick on the other chip that was in here, so I just put a different one in. So yeah, the one that was in it had a broken leg, and whoever they tried to solder it to, remember that solder mess that was on pin 40 of the socket? Yeah, it just, so we've got a good 8080 in here. And I replaced this. I removed this RAM and I tested it. It was fine. Put it back in the board. This 298 was the problematic chip. I resoldered all of these connections and I cleaned all my work really good. I replaced all the electrolytics. Remember, it had bad electrolytic capacitors on it. So yeah, now we're working. And it looks good. I'll be right back. Let me check. I'm going to check into testing controls on this thing. I know it uses encoders. It uses some of those angle encoder things for movement. I'm not so sure I can test that, but I'll see if I did before. I know I've worked on space encounters before, but I don't know if I tested the movement. So let me look into that.